Hello everyone, I'm Harold Mullen. Welcome to TXAPA Live. We're delighted that you're joining us today for another great program about improving the quality of asphalt. And today, our show is about improving quality asphalt through enhanced process control. To bring that information to us today is our Director of Technology and Engineering, and that is Mr. Jim Moore. Jim, come on in and join me here today.
How you doing, Harold?
Doing great, man. How are you?
Good. Welcome to the studio.
Well, you know, I was just going to say,
we've made some changes.
You have made major changes. I come in here prepared to do our TXAPA Live, and lo and behold, I'm standing up. I'm behind a teacher's desk. Tell me about this.
Well, you know, we have done, you know, the COVID brought a lot of changes to everything that we did. And one of the things that we had to do is we had to start doing a lot more teaching. And kind of sitting at the chair and teaching is boring. It's boring for everybody. So we had the capability of an extra room here. So we we stole it, and we started bringing stuff in. And Harold's like, "Where'd you get all this stuff?" So anyway, so we have set up a studio here at TXAPA. And the way things have evolved is now we are teaching live from TXAPA a number of programs, and we plan to do some more. So it's exciting. Let me give you a real quick tour of this and show you around. So this is us, so we can get us out of the picture here. And this is us from the side view. This is the inside of the studio, and there's lots of stuff in here. So what you're normally seeing is a camera right out front here, and then there's a big TV that you see a reflection on. When we teach, we bring everybody in Zoom up there on that big TV. So I'm looking at them, you know, almost full size. Essentially. And so that works pretty well. So then we've got a main camera is right there in front of it. But what you're seeing here is kind of a wide shot of the whole room. So we've got lights up above. We've got our teaching desk, as Harold called it, and we can reconfigure the room to do other stuff. All the stuff down here is all the computer stuff. There's 3 computers, a video, audio recorders, all kinds of stuff down here that allows us then to run the program, and we run it off of a little iPad up here, which controls everything. So that's pretty much what we do, but it allows us then to be a lot more touchy-feely. I've always tried to use props.
Absolutely.
In everything that I've used, in everything that I do, and I just find that it's more effective.
And Jim, I don't call those props. I call that your toys. So
well, you could call them toys.
But what they really are interactive tools, is what they really are. Yes, so I just wanted you to show us a little bit about the interactive tools and how you use them in our educational programs.
Well, good point. Okay, so we've got some additional cameras here. So we've got to do a camera down here where we can show things, and here's a little setup that we've used this week, and we can look at it from a couple different angles. We can even split screen it, and so we can do a lot of things. Again, everything within this realm that we're working on is something we can work. So here's an example. All right, so let's talk about something we did this week. This is a layer of asphalt. It could be used as a tongue depressor or a popsicle stick, a really big one. Can you bend that?
Sure.
Got a lot of flex to it, right?
Pretty easy.
Okay. What if I wanted to make it stiffer? I'll just stack another one on top there.
Another layer. Okay.
Yep.
I can still bend it.
Still pretty flat. Okay, one more. You're strong.
All right. Hey, all right. Look at this. Okay. Yeah. Oh,
still.
Very big. Yep.
Yeah, still
flexible.
got some. Okay.
Flexible.
Let's change that out. Here, try this one.
Ooh. No.
No. They're both made out of 3 layers.
Oh, they are.
What's the difference?
These are glued together.
They're glued together. So our analogy there is tack.
Okay.
And so the idea behind something that's really flexible, these layers will slide over each other. Once they're glued together, they're not going to want to slide over each other. And so we think about that in terms of pavement performance and pavement design. So let's jump down here to another camera. So here's our clay subgrade. We've got a lot of clay in Texas.
Yes.
Okay, so we put our asphalt on top of that, and we would load that. We want that load to distribute down through the clay, where we don't damage or exceed the strain capacity of the top of the subgrade. So typically, what we design for is tensile strain on the bottom of the asphalt layer, compressive strain on the top of the subgrade. But you notice I can still push down on that. And even if I stack multiple layers on there, I can still push down, and repeated load is going to eventually damage that subgrade, which is running. Okay,
You
permanent
bet.
deformation.
Not good.
But when I glue everything together and I load it, now that load is spread over a much bigger area. So now the importance of tack, even though it's a pretty minor little item, is a huge issue relative to pavement. Now, if I want to build a really strong pavement, well, I stack some more asphalt on top of that, and I get almost to a semi-rigid state. And those are the kind of examples that we use in the programs that we're teaching. Now we're teaching a couple different programs.
Well, Jim, that really, really helps me, especially if I'm doing online education, online training.
Yeah.
I'm such a visual learner. I get the concepts at that
Yeah,
point.
and that's kind of the whole idea is we want to make it interactive. We want people to understand it, and you know, I don't learn in one particular mode. You know, some people are auditory, some people are visual, some people just, you know, whatever. I like multiple things, and I think that helps reinforce what the message is and gives people something to kind of identify with. So we do a lot of different stuff. There's a whole wall of stuff over here behind you of things that we've got that we use as part of the classes.
So Jim, the good news is you have two kinds of classes going on now.
Yeah.
You have an inspector's course as well as the engineer
Asphalt.
Yeah.
Yeah. The inspector course we started back in February, and we're back running it again, and just finishing up a class this week, and we've got another class starting in December, and these are 6 sessions, 2.5 hours apiece, so twice a week for 3 weeks. So it's a lot of work. It is. And we also give them homework. We use a learning management system, which is an online repository of information to take quizzes and do homework assignments and house resources and stuff. And so that's an ongoing thing. One of the big things that we just finished in November was our pilot for the engineering course.
Yes.
And this is we call it Engineering Essentials or Asphalt Essentials, which covers maintenance, design, materials, and construction. And one of the big things we try to do with that is the same kind of thing, but in a lot more detail. We can talk about stresses and strains and that where the inspectors are like, I'm not sure. But we ask the inspectors to inspect to make sure projects are built. The engineers need to know more of the details about why we're doing something and the importance of the engineering fundamentals in the process of. So that gives us the ability to really kind of hone in there. So we just finished the pilot. Had a really good success with the pilot, and we're making some tweaks as you would always normally make. And so we are just released to January dates for next year. And so
I just want to point out this is a dynamic class that you have, or classes that you have, and you're now able to apply these great interactive tools in both classes. And that's some of the feedback that we got back from the inspector's class that you brought over to the Engineering Essentials class is to use these tools, and you even came up with even better enhanced tools.
Yeah,
so,
I wake up at 3 o'clock in the morning thinking about stuff we can do, so it's lots of fun. So.
But I wanted to let everybody know that you can go to TXAPA's website, Texas Asphalt, and you can sign up for all these classes that we have now. You can set Jim's classes. The inspector course is the schedule is out for several months now, so you can sign up there. $195 for that class, and also you can sign up for the Asphalt Essentials Engineering course. And from now through the end of 2022, any engineering classes that we offer are free. There will be no registration fee for those. Our board of directors is very committed to getting the education message out there, so we want to provide that free for all engineers, those that are involved in asphalt pavement and pavement design, maintenance, construction, materials, all those type of things are covered.
It's going to be a busy year.
Yeah, it's going to be a real busy year. Jim's going to have lots of classes going on, so we want to encourage you to do that.
Yes, sir.
All right.
Hey, we got a program to do today.
Hey, we do. We really do.
Let's
and
get after it.
I'm really kind of curious about that because we're talking about enhanced process control to improve the quality of our asphalt pavements, and everybody's going to want to know who's that for and what's in it for me.
All right. Well, let's get to that. All right. So let's go ahead and talk about improving asphalt quality through enhanced process control. And Harold, you feel free to jump in any time as we're going through this process. So You know, as we're building things, we really need to understand all the power of the information that we have when we're doing it. So let's take just a second, talk about what's in it for me, okay? If you're a contractor, really the power here is seeing your trends and being able to make changes before you get out of spec. So you can maximize your pay factor. And pay factor for TxDOT perspective is quality. So they're totally related together. From the agency or TxDOT or the city or county, when you start to see that, you can better understand the data, and so you can understand with the contractors talking about what's going on. So essentially what we're all talking about is better communication and better mix quality, leading to what, Harold? Longer lasting.
Longer lasting asphalt pavements.
And that's what we want. So that's what we want. And it also will make your daily debrief a breeze. And we can talk about daily debriefs all along. And that's one of the things we talk about in all the classes that we talk about. The PIQs everywhere we're talking about consistently is communicating daily what's going on a job site. So that's a key aspect of the whole program here. All right, so let's keep going here. And higher quality asphalt is what we're looking for. Get my belly out of the way. We want to make this easy. Okay, we want to make this easy. So you've got asphalt plant operations and you've got laid-on operations. There's lots of things happening at the plant, but essentially the things that we're testing moisture, temperature, gradation, binder content, and volumetrics. Out on the roadway, we're also measuring temperature as well as density and ride. So these are the things, this is the data that we have that we're also getting paid for in many cases. And now we want to be able to use that information a little bit better than we have in the past.
So Jim, you're saying that this enhanced process control can make this, I love punching the easy button. It's going to make our lives easier?
Oh, absolutely, absolutely. You know, pick any one of these things and we could talk about it. You know, I mean, surface preparation to density to testing, all this kind of stuff. So let's get involved in a little bit more detail as we kind of go in there. You know, when we talk about a mix design is just a recipe, right? It's a recipe of certain combinations of different aggregates mixed with a certain combination of binder and reclaimed asphalt pavement to give us an end product. Really no different than what we see in the grocery store when we got a box mix of brownies. Now everybody's got a different brownie mix, and you've got different brownie mixes for different occasions. You can get ones with sprinkles in it for your birthday if you want. So, but we can have different things in there. But again, they're just recipes. But let's talk a little bit of detail. Now I've got here, Harold, here's your first quiz of today. Okay?
All right.
Producing asphalt is either like shooting craps or rolling dice, building a Swiss watch, or making beer. What do you think?
Well, you know, shooting craps is a big gamble.
Absolutely.
That's for sure. So that surely is not it. That Swiss watch can be extremely complicated and expensive, so I don't think we would go there.
No.
So, you know, that beer has, you know, it has a great outcome, you know, and I think that would be it. C.
All right, so you punch C. You hit C for me. All right, hit C.
Oh,
there it is. There it is. Come on, I'm teaching Harold how to use the green screen. Okay, the answer is C. Okay.
Oh.
The issue here is we are using naturally occurring aggregates, naturally occurring ingredients, aggregates, and asphalt binders, but they can vary over time, just like a hop crop can vary. Our aggregate can vary a little bit, or our binder can vary a little bit. So we have to have the need to continually tweak and adjust the material as we go through the process, and we are also making this in mass quantities. Just like they're making Budweiser, Miller Lite, or Lone Star beer, they're making a whole bunch of it. So,
you know, Jim, you've gotten really good at the pointing. I like that.
Yeah, I'm getting better.
Yeah, I just want to point that
out. You should see me when I'm teaching, so I get hung up every once in a while. I'm going all different ways. Ideally, the end result is it meets the customer's expectations, right?
You bet.
So if the beer doesn't taste right, or the beer changes a whole bunch and doesn't meet, you're not going to buy it anymore. If our asphalt doesn't meet the expectations of our customer, well, guess what? They're not going to buy it anymore. So this is the opportunity we have, and just making sure everybody understands that there's a process here. You don't just plug in and in one time and you're going to run, 10,000 tons of the same material. The QC people are actively working every day, making little adjustments to make sure that mix design meets specifications as it gets out of the roadway. So at the plant, there's lots of opportunities to make improvements out here. from the job mix formula to the aggregate to moisture control to temperature control, even to dust and binder quality as well. And finally, we're going to get that mix into a truck and get it out to the job site.
You know, Jim, there's a couple items there I just wanted to point out that I seem to have really learned from you and Chuck and going out to the plants that we have out there. And number one of those is moisture. It seems like we really don't pay a lot of attention to our moisture sometimes.
Yeah, I mean, it's the moisture content. You know, asphalt plants are built on a certain specification. So many tons per hour at a certain altitude and at a certain moisture content, which is 5%. You go to most asphalt plants and they can say, hey, what's your moisture content? They're going to say it's 5%. Is it actually 5%? Well, if it's West Texas and it rained in 3 months, it's probably not 5%.
Right.
If it's Houston, on most of the days during the week, it's probably not 5%. So we have to be able to adjust that. If my moisture content varies, my plant production is tied to that. My asphalt control is tied to that moisture content. So if I'm not adjusting that, I could have tweaks in my asphalt content just because I'm not managing my moisture properly.
And then on the other side of that is that dust to asphalt ratio.
Oh, absolutely.
The dust coming back into your mix.
Yeah, a little bit of dust goes a long way. Okay, and on a kind of a standard asphalt operation, probably only about a third of the dust ends up going through that big vacuum cleaner we call a baghouse.
Yeah.
But we got to get that back into the mix. In some cases, most of the cases, we put it back in, but we have to meter it back in, but it's going to go out at a given rate, and it's going to come back at a given rate, which is adjustable. But even the quality of that dust is going to change depending on how we run the plant. If we're running the plant really fast and really slow and really fast and really slow, that's going to change the properties of that dust, and so that could change the actual mix properties that we see coming out of the lab, or how its mix is actually performing in the field. So there's some issues there that we just need to keep a handle on. So again, it all goes back to consistency and in the whole process. So let's move on to the roadway. Again, all these can affect test results, and we're going to get the test results here in just a second, but I wanted to talk about all those little things that can affect that as well. So on the roadway, we got temperature. Okay, so we're gonna haul the material. You know, how far are we gonna haul the material? In what weather? Okay, tarps. It's November now. Okay, and what thickness we're gonna be laying it? Just the process of unloading that material out of the truck into the MTV. How we run the MTV could matter. Obviously we're looking for mix uniformity and consistency in the whole thing, but when we get to the paver, you know, there's a lot of stuff that we cover in these classes, and the stuff that Chuck covers, and whenever he's out talking, these are the same these are these fundamental principles of how this stuff works. And then when you get back down to compaction, well, we got to make sure we get density.
You know, Jim, I'm going to try and use my finger here to do the pointing.
Let me get out of the way.
Yeah.
Let me get out of the way.
One thing that you have always harped on is temperature control. Because we were out there on a job site not too long ago, and you were the only guy out there who had one of your useful tools. Yes.
Yeah. I keep, and actually we just bought some more. Chuck bought some more to use in the field. Temperature is absolutely critical. Temperature sets the pavement up to allow us to roll the material. Okay? And if the temperature is varying or the temperature is too cold to start with, we're never going to get the density. And if we don't get density, we're not going to get performance. They're completely tied together, straight on down the road, and I don't care what anybody else says. I know it. That's it. And we're done arguing over it. We got to get the material compacted in the right place.
So that's certainly one of those very important elements. And one other thing I just wanted to point out also was
back on the finger. There we go.
The mix unloading. You know, we pay a lot of attention when we load our mix. We know we have a system over there, the 3-drop and those type of things. But the unloading process, sometimes we're not really keen on that, but that's going to be part of this enhanced process that we need to really pay attention to.
Yeah, just be, you know, like you said, we've spent all that time getting it together in a nice tight mass at the asphalt plant, getting it in a truck in a nice tight mass. But when we lay it out on a roadway, or we dump it into the hopper and we don't dump it in properly, or we stretch it out, or we get too thin between truckloads, guess what we can start causing again? We can start causing segregation. So segregation, obviously we know that's not a good thing. That's detrimental to the quality of it. So we need to be able to control our process a little bit all the way. We always want to keep the mix in a mass, no matter what we're doing. If we're shoveling it, we want to keep it in a mass. You know, if we're making it, we want to keep it in a mass. So, and anywhere in between, we want to make sure we keep that mix in a mass. So it's all this stuff's important. Again, all these can affect the test results, and all these can affect performance. So these are the types of things that we want to look at. So we've talked about numbers already, okay? And so here's some numbers, Harold. And I know, I know your background is not engineering, but you've been around a long time.
Okay.
So tell me what you think. How do those numbers look?
Yeah, they're pretty good, but I don't know what to compare them to. You know, they're static numbers to me,
Yeah,
right?
they're static numbers, and so that's what happens a lot of times is we see the numbers and then go, well, are they? Yeah, that one seems to be in. That one seems to be in. Good enough. Okay. The big question is, did it pass?
Exactly.
Okay, that's the big question.
Yeah.
And then once it passes, they go into a folder or get off, load it off somewhere. So that can be a problem. There's a lot of potential here to use this information. Now, here's a little bit more information, Harold. How does this look to you?
Yeah, this looks very, very complicated. Yeah, I can take a lot from that. Yes.
Exactly. And so when you've got a big pile of data, sometimes it's called data overload. You just I'm not sure. I'm looking for outliers or whatever. But it's not really a good way of really using the data effectively. So let's break it down and let's graph it. Okay, now we talk about using process control charts. It's in the specification. But let's actually start using it. And this is the enhanced part that we were trying to get to a little bit earlier. That enhanced part is looking at the data in this whole process. So here's our target line right here in the middle. And then we've got these other little dashed lines above and below. Do you know what those are?
What's that?
Okay. The first set of dashed lines is one standard deviation of the variability of that material. Okay, now you contractors, and we'll talk about this in just a second. The second set of lines is 2 standard deviations, and the third is 3 standard deviations. For a normal distributed material, which we generally consider asphalt to be, 1 standard deviation, about 66% of the data should fall within that, okay, on a normal condition, okay? 2 standard deviations is about 95, 96%, so most all of it. And about 3 standard deviations, I think it's like 99.6%. So pretty much all of it, but not exactly all of it. There could be, you could get a flyer out here, down here, and still be a statistically valid test. So this is the process that we have to go through. So again, we got to make sure we sample right, and we're assuming all along now that we've sampled right and we've tested right. And now we're looking at pure material variability in this process. So we can look at it a number of different ways. We can look at single tests, average tests. We can use the control charts we just talked about. We can use standard deviation, which brings up horror from people who had statistics. We could use advanced statistical process control. And we need to understand the process capability. But in a reality is I never want to make a judgment on a single test. I never want to make a change on a single test. There's too much money involved. And there could be a whoops. Heck, a half a shovelful difference if some of that coarse material fell off or some of that fine material could throw my asphalt content off. I want to verify that. So I'm always looking, I always want to see multiple tests before I do that. Now, if I do a single test and it's a QC or it's a process test and I don't see something I like, I'm not going to wait, 2 hours. I'm immediately going to go get another test and see what's going on. So that's better. Control charts, I think they're extraordinarily positive and we need to use them wherever we can. Standard deviations get a bad rap. But it's it's simple. With the old computers, you had to do all the math and stuff. Now you got Excel. It's a function at STDVE and do the line and it'll calculate it for you. So, but we're not, there's all kinds of higher order statistical process control that you could get into. We're not going to talk about that today, but we do want to talk about process capability. What do you think that means?
Great question.
Great question. It's essentially what your normal variability is on a given day. So any number of these properties, let's take binder content. Well, if the specification is plus or minus 0.5%, and I'm designing at 5, so I got 4.5 to 5.5%, I got to stay in that tolerance. What can you actually produce within? Okay, is my process capability 0.5%? Well, it better not be, because then you're going to have a problem. Okay, because any sort of tweak off that average and you're going to be out of spec. But is it 0.3? Is it 0.15? Do you know? And I think that's the question, and that's the question that we're trying to have that discussion about today, is starting to understand what your process capability is to better understand how to control the material. The lower your standard deviation, the more you know if you have to make a change, you can figure out which way to move. If you have a huge standard deviation, I'm not sure what to do.
Yeah.
I'm not sure what to do at that point. So what can you rely on a daily basis? So there's some rules that were developed, and this manufacturing idea started actually looking at data started back, I believe, in the 20s. Further codified in the 50s. Western Electric came up with some ways of looking at the data. Same chart. You got your average in the middle, plus or minus 1 standard deviation, 2 standard deviations, 3 standard deviations in the process. But then they said, okay, what happens if I'm way out? Okay, this is that I've exceeded my 3 standard deviations, and do I just, well, it happens, that's a pretty small percentage of time. There's probably something wrong there, okay, that we want to look at pretty quickly. And so in this case, in the second rule, and again, there's 6 to 7 to 8 rules depending on which source you get. Rule 2 is 2 out of 3 consecutive points fall in zone A or beyond. So you've got 2 points in your 3rd standard deviation. Now you're at your upper limit there. But if you don't know what your standard deviation is, it's hard to figure out where to even start. So here's the rules themselves. They've even named them, and they talk about what they are. And we're not going to go through in much detail here today, but you can, any sort of Google search will probably bring up 150 of sources of this. Is just look up Western Electric rules and how to interpret them. The neat thing about this was, I found this the other day, is within those rules they further codified maybe what could be going on. So you look at this one, Harold. What's number 1 at the top there? Let's try out your finger again, see if it still works. Okay.
Here we go.
Keep going. Number 1. What's at the top?
Yay! Right there.
We got a new guy.
All right.
We got a
new person doing a job.
We got a new person doing a job. So they may not know all the intricate details of the process. They may just had a measurement error. Maybe they maybe they transposed the number. That can happen. Okay. Or we didn't do a step. We skipped a step, or we didn't do a step, or we didn't complete a step.
Or took a shortcut.
I took a shortcut. Now, right across our parking lot is the HMAC, where they do all the certification and training. Okay. And I know Corey and his band of brothers and sisters over there. They preach every day, run the test the way it was expected, it was designed to be run. And don't take any shortcuts. Because when you take a shortcut, then we don't really know what to compare against. So
Exactly.
This is the process of going through these things. And there's some cool stuff in here. If you get certain kind of trains, you say, well, maybe something's just wearing out. Gee.
We have to do some maintenance on our
We have
equipment.
to do some maintenance along the way. So just real quick here, there's power in the data. Don't be powerless. Use the data. Get the data, use it. It's already out there. So let's talk about the roadway real quick. This is a favorite video of mine, the clip that we picked up back during COVID. This is on Westheimer. And if anybody been down Westheimer, you know what, you could never do work in the daytime, but because of COVID, they were actually working the daytime. You can see 1 roller, and you can see 2 rollers breakdown rolling behind the paver, and I can still see everybody behind the paver, which means they're working closely. Look at that reversing. See how they're turning crosswise, and they're not stopping square as they reverse? I love double breakdown rollers because
Good
they
job.
keep each other in check, and they can cover the whole width of the mat in one pass. So I really think there's a great opportunity here. I can cover that full width in one pass with these 2 rollers. So again, here's the same, there was the same roller going the other direction, different crew doing the same thing. So they have a standard operating procedure. They're on top of it. And that mat looked absolutely gorgeous. When we talk about density, that's what we're getting paid on. Okay, we're getting paid on in-place air voids. And so we need to know what those numbers are. We need to understand the effect of moisture and density and temperature on density.
Mm-hmm.
And we also, again, we come back to consistency.
Mm-hmm.
We're always preaching consistency because guess what? Consistency yields consistent results. And so the best management practice of the BMPs here are understanding how to balance that operation between what the plant can produce, what the trucks can haul, what the paver can lay, and what the rollers can compact, and having them all kind of working on the same play sheet, if you will. From the QC perspective, correlating their gauge to course, field course. It should be done every day. Okay, we should know what we're doing before we take a core. They should once they mark the location, set the gauge down, get some readings, log it in a book. When they get the core results back from the lab, they write it in there and they figure out what the running correlation is between the gauge. So if I dial my gauge into my cores, that means I know before I finish rolling what I'm going to get paid within with a high precision. The QC tech needs to stay focused on density and rolling patterns. When folks do that, they do really, really well. We also have to watch the weather. Again, it's November. Okay, times are changing, the season's changing, and that as that day changes, you're going to have to adjust that rolling pattern as we go. And again, I'm a big fan of dual double drum rollers. Different people have got ideas, but I've seen that work with some pretty severe specifications. So kind of wrapping it up here, from this perspective, we always want to determine what our capabilities are, right? Harold, can you still run a 4-minute mile?
No, sir, I cannot.
Okay, all right, well, neither can I, but you got to know a man's got to know his limitations, right?
Absolutely.
So we got to understand our capability. But if I was plotting and I was running before my knees gave out, I used to plot my data, and I kind of knew what I could do, and it wasn't even close to 4 minutes. So that just let you know. But I'm going to look for trends. I want to look for trends in my data, and this is a big one for everybody out there. Be real careful about making a single point change. If one piece of data says there's an issue, always want to verify that, validate that. You may want to put everybody on alert, but we want to make sure we're checking that as well, and make your change when you got your data to support it. And that means what? We got to be looking at the data. Okay, so and
sharing that data.
Oh, I tell you. You know, one of the things we talk about, come back in here, one of the things we talk about in the classes is this group text idea, okay? Where when we set up a job, pre-paving, we exchange all the phone numbers from everybody's cell phone number, and you set up a group text.
Right.
Put everybody's in there. So you want your 1As at the plant, your 1Bs in the field, your inspector, your superintendent, your QC manager, maybe even your plant guy, all on this group text. And so as soon as you start getting data, or as soon as you start having information, you just send a text out. Everybody gets it. Everybody's in the loop. There's no surprises. I hate surprises.
Oh, yeah.
And I know contractors don't like surprises, and I know DOT doesn't like surprises. So this is a great way of doing that, But when we do make a change, okay, we only want to make one change at a time. And here's your process. If it helps, keep it. If it hurts, put it back the other way. And if there is no change, look for interactions and cost implications that there might be with the data itself, because that's really what we need to be doing in order to make good quality asphalt. So I think we're pretty much go. Remember to chart your success. We want to use that, and remember, quality is not an accident. There's a lot of work that's being done to make these pavements done, make these done properly. And a good QC program is proactive, not reactive. And we want to make changes before they become an issue. If I'm looking at my data and I see a trend in my data, I can then make that change, make a small little adjustment, and stay in and ride it home. So that's pretty much it, man.
Well, I think right there in that little paragraph that
you had to active word
there,
didn't you?
I had to do it one more time. It's proactive.
Absolutely.
Proactive. We want to be proactive in our approach. We want to be proactive in keeping up with the data.
Yep.
We want to use visual charts so we can chart that, so we can see the visual learners can actually keep up with what's going on. We can track our success that way, or what might be happening. So, Jim, thank you very much. We certainly appreciate the tour of the studio.
Anytime.
And certainly,
Hey, if you buy Buda, come by. If you buy beautiful Buda, come by TXAPA, and I'll give you a personal tour. Come on in.
Absolutely.
I'll even let you play with the green screen.
I mean, who knew that TXAPA was going to have a studio one day? And like you said, we've adapted. We've had to pivot, and because of COVID, and it's just a great tool that we have now to share with each other. More communication. We get to train through this method, so it really is just a great situation that we'd love for you to come by and see us.
Awesome.
If you want to sign up for those courses, once again, go to our website, texasasphalt.org, and you can sign up for the inspector's class as well for the engineering essentials class.
Just click on the education bar, and they'll pop right down. You can click whichever one you want, and it'll take you and walk you through the process.
And Jim will be the instructor. He'll be right here behind the old teaching desk using all of his interactive tools to bring you through that class. Or toys, that's right. That's right. Hey, thank you so much for joining us. We really appreciate it. We look forward to seeing you next time on TXAPA Live.
See ya.